Probably most of you have heard at some point some negative comments about agriculture and livestock in particular, and our role in greenhouse gas emissions. Today, we're going to look at those greenhouse gas emissions, where those numbers come from, why we care about them. We're going to look at how those numbers are determined. And then we're going to actually look at the role of livestock and agriculture on those greenhouse gas emissions and go over why some of that data is misleading. And then we'll look at what agriculture can do to reduce our greenhouse gas emissions. Okay, so we're going to talk about our greenhouse gas emissions. I was covering we'll go over what are the greenhouse gases, why we care about those greenhouse gas emissions, how they're determined. We'll look at the role of livestock in agriculture and why some of that data is misleading, and what agriculture can do to reduce our greenhouse gas emissions. So first, what are greenhouse gases? They're gases that trap heat in the atmosphere, and so they act basically like a giant blanket around our Earth. So the sunlight emits UV light, visible light, infrared energy. That energy bombards the Earth. About 30% is reflected back out to space right away by the clouds. 70% hits the Earth in either the oceans or the land. It warms up the ocean and the land, and as that warms up, that releases infrared energy, which then bounces back up through our atmosphere. It may bounce all the way back out to space. It may hit a greenhouse gas molecule and warm up that molecule, which then may warm up other molecules and then bounce back to Earth, or it may bounce out to space. But basically, it acts just like a blanket. The more greenhouse gas molecules we have in that atmosphere, it's just like putting on a thicker blanket. So if you have a real thin blanket and you're cold, it doesn't necessarily keep you warm, but if you put on more blankets, or if we add more greenhouse gas molecules, it traps more of that heat in by the Earth, and that's what we're actually worried about, how that can help warm up the atmosphere too much. No, it doesn't want to look. Okay. Our sources of greenhouse gases, when we look at them, there's both natural and human-made, or what's called anthropogenic. Natural sources of greenhouse gases are there's all kinds of sources. The ocean emits a lot, wetlands emit a lot of methane, termites even. They actually give a credit for termites. We don't seem to think we'd worry about that too much. But if I remember correctly, they emit about 200 million metric tons of carbon dioxide. So all those natural sources we really figure we can't do much about, so we don't really worry about them. We do worry about the anthropogenic, or the human-caused sources. And of those, the ones that we really are concerned about are the carbon dioxide, methane, nitrous oxide, and some then we'll throw in the fluorinated gases. When we look at those gases, they're not all the same. They have different warming potentials that can heat up to a different amount. And we also, as they look at those, they also look at a lifespan. So they use what's called a global warming potential to weight, or kind of say how bad each of those gases are in relation to carbon dioxide. You'll note here on the screen that methane has now a weighting by the new EPA values of 28 to 36. The old weightings, some you'll see all the way down to 21. Some you'll see at 25. EPA just had it at 25, and you're probably going, well, why is this changing all the time? It's kind of a frustration. Some depends on the time frame that they're looking at. So they're looking at the impact of that molecule over a set time frame. Generally, it's 100 years. Some only use a 20-year time frame. And then they have different ways of kind of crediting that. So methane now is getting deemed for being a precursor to ozone, which can also create problems. And so they've kind of bumped up some of those weights. If you look at it, carbon dioxide actually has a lifespan of about 1,000 years. Methane has a lifespan of about 10 years. Nitrous oxide has a lifespan of a little over 100 years. And those fluorinated carbons that we won't really talk about too much, those actually have a lifespan of 1,000, or a warming potential of 1,000 to hundreds of thousands, depending on which ones they are, compared to carbon dioxide. And so that's why, even though they're extremely small in quantity, they have such a huge warming potential that they look at those. Now, why are we concerned about greenhouse gases? You've probably all heard some of this. The biggest thing is that they attribute this to a lot of our extreme weather events that we're getting. So as the earth warms more, and so we get more warming potential in the oceans, that shifts some of those ocean currents, that then helps shift some of the air currents. They attribute that to then some of the extreme weather events. So we should expect to see more droughts, more huge floods, bigger hurricanes. And that's a concern. The rising sea levels, as we can see the pictures of the glaciers melting, as those melt, that will raise our sea level. We're already starting to see some areas out in the northeast part of the United States that are starting to run into a few problems with that. Along with that warming, will most likely be plant and animal extinctions. They say that will contribute to ocean acidification. That will also then help trigger a whole cascading series of animals that no longer thrive in the ocean. And bottom line, they think that this will end up creating some major shifts in the climate and where we can produce food and how that will impact our human population. If we look at the global greenhouse gas emissions by sector over the last 26 years or so, from 1990 to 2016 on here, you can see that electricity is really one of the biggest sources, and it's been increasing right along. Transportation is the next one, and it's also increasing at a pretty good clip along in the manufacturing. Those top three really are primarily due to the burning of fossil fuels. That's how we're getting that electricity, how we're getting the transportation and the manufacturing. Agriculture is kind of the fourth one on there, and if you'll look at that globally, agriculture is increasing in our greenhouse gas emissions also. Here's just the carbon dioxide emissions from fossil fuels, and this goes back to the 1751 through 2017. You will note that the huge increase that we're getting from shortly after 1950, and that really coincides with a lot of our industrial, growth and how we've increased our transportation. And so the United States is kind of we're at kind of a consistent level right there, but China is growing exponentially. India is expected to grow. We haven't slowed down, and so it is anticipated that unless we start making some changes, that things will continue to advance more and more. Now, how do we determine greenhouse gas emissions? They're difficult to measure. So you're trying to find gases and measure gases as they're released from a lot of microbial actions. And so you're trying to go out there and put the covers on and take little air samples. They may put up little posts and have little traps to catch some of the gases. Again, you can do that for a small segment, but we really can't go across the whole world and say, oh, and this is exactly how much is being emitted. So they take small little snapshots in time, gather data, and then they put it into models to try to predict how much is or estimate how much is being lost. The trouble with gases is that they're highly variable based on temperature, humidity, wind speed, pH, pretty much you name it, it impacts our gaseous emissions. And so even if you did a really robust study with some of the bigger LiDAR systems for a week at 4 different seasons, you're still having to extrapolate for those other weeks. And we see, just even in the emissions, we see huge differences between the daytime emissions and the nighttime emissions. So it's very highly variable. And then you put it into models, and models make a lot of assumptions. That's how we have to do it. But your model is only as good as your assumption. So bottom line, we can try really hard to get really good emissions, but you will have a lot of variability based on the data that you're using for those emission rates and the models that you're using and the assumptions that they have in there. And that's part of why when we look at greenhouse gas emissions, you're going to see numbers that are all over the board because they're using different models and different data. There's 2 primary ways of looking at greenhouse gas emissions that we should cover. One is called the life cycle assessment, And so that's where we actually go. It's a cradle to grave system. So if we're looking at transportation, we would actually go and look at the emissions from the raw material extraction to the manufacturing of the components for the vehicle, then the assembly of the vehicle, the emissions from the fuel, and then the actual emissions from the tailpipe, which is what we tend to think of. And then as we recycle the vehicles, the emissions in that process. That's called the life cycle assessment, or LCA. The other method is what's called a direct emission. So that would be ignoring all of the rest of the stuff, and we're only looking at transportation. We would only measure the emissions from the tailpipes of those vehicles as they're driving on the roads. So as we now look at what agricultural emissions in the United States, the two primary sources are livestock and soil management. So soil management, that's really mostly from the nitrous oxide that's being produced from the microbes as they decompose organic matter. It's also some from our fertilizer and how that decomposes or goes through the nitrogen cycle. If you have actually been looking at any of those, the EPA just changed their methodology for how they determine the soil management emissions. And so soil management is now a slightly larger portion of the emissions than livestock, and it used to be just the reverse. So if we look at the soil management emissions, that primarily comes from nitrous oxide. That's from our fertilizers. So as the fertilizer is applied, it will go through the nitrogen cycle, become nitrate, and then it can go through the process, especially in wet or anaerobic conditions. So fortunately in Utah, where we're drier, we don't have as much of this, but it will be converted to nitrite, to nitric oxide, to nitrous oxide, and then ultimately to dinitrogen gas. If that nitrogen fertilizer is converted all the way to dinitrogen gas, N2, it's just released back in the atmosphere, it's inert. Environmentally, it's no harm whatsoever. It is a huge economic loss, though, and there are a lot of farmers, especially as you move further east where they get more rain, as they apply the fertilizer to their ground. If they get a lot of rain and the soil becomes saturated, they can lose a lot of their nitrogen. It just volatilizes off, and they've spent the money for it. They're not getting to utilize that resource. And even if it goes all the way through that process to dinitrogen gas, they've lost that money. The unfortunate part is that we lose some in every single one of those steps. And so that's where some of that nitrous oxide is coming. For soil management, we also get some of the decomposition of residue from the microbes and the carbon dioxide that they release. Tillage releases or encourages more microbial activity to decompose real fast, and so you'll get more emissions that way. The other one that they really look at a lot is the saturated soils. And so rice, because they saturate that ground for a while, has a lot of methane emissions. We get methane off of that. And so typically rice it's just like a wetland in that way, only it's only part of the year, but it has a lot of methane emissions. When we look at the livestock emissions, it basically breaks down into three major categories. There's the enteric emissions, and that's the biggest category, feed, and manure management. And if you look here on how they've broken it out in this one, they even have a portion for feed just from rice. So as you feed rice hulls, there's a slice, a portion to the feeding of rice hulls in that. Now, this is probably what if you've heard data or negative comments about agriculture, this is where it most likely came from. The Food and Agricultural Organization issued a report in 2006 called Livestock's Long Shadow. That one attributed livestock as contributing 18% total of the global greenhouse gas emissions. 18% just for livestock. And then they said that that was more than the entire global transportation system contributed. Okay, so especially anybody that isn't real in favor of livestock and especially cattle grazing, They've jumped all over this, and this number keeps being reported over and over and over again. The other thing they'll oftentimes report, they have that livestock contribute 9% of the total carbon dioxide emissions, 37% of the methane emissions, and 65% of the nitrous oxide emissions. So oftentimes you'll see little reports and they'll say, you know, of the methane and nitrous emissions, or not counting carbon dioxide, agriculture, livestock contribute, and then they have these huge percentages. They can twist those numbers so that it looks like we're extremely damaging. Okay. And this really, there's some issues with this one, but this has been used more to blame agriculture and livestock in particular, especially cows, for destroying our planet than pretty much any other source of greenhouse gas emission data. There's two problems with this one. So if you hear these comments, first off, the methodology that they used for the assessment was different. So they used the life cycle assessment for calculating livestock emissions. So they went clear back to the cost, the emissions that would be produced as you produce the feed. They actually even also charge in there the emissions from the changes in land use. So in the developing countries, if they were destroying rainforest to put in pastures to graze cattle, they charge that loss of rainforest as a greenhouse gas for the livestock. But when they looked at then the transportation, the vehicles, they only took tailpipe emissions. They only used direct emissions. Those are two entirely different scenarios. And so one, they're counting everything, and the other one, they're only looking at a tiny little slice. So if we go back to that, they said that transportation at that point in time contributed about 14%, and livestock contributed about 18% of the total global emissions. But if you looked at because they were only looking at direct emissions for the transportation, at that, direct emissions for livestock would only have been about 5% of the total global greenhouse gases. So you have to be real careful when you hear numbers or look at numbers as to what they're actually reporting on. The other issue with this is that global emissions and emissions from the US are not exactly the same. They're not representative. So when we look at these on a global basis, and this is both the soil management and livestock, but agriculture contributes about 24% of the greenhouse gas emissions. In the United States, we only contribute about 9%. Now, some of this isn't just that we're so much less. Some of this is that the United States has a lot more emissions from transportation than some of those developing countries. So we're just a smaller percentage of that, of our total. But some of it is that we are much more efficient with our livestock production. And if you wanted to know just a crude number, ballpark, about half of the emissions from agriculture are for livestock and about half are from soil management and other things. So when we look at the global versus US greenhouse gas emissions from livestock production, or if we put it on a carbon footprint basis, so greenhouse gas emissions per unit of production, so per pound of protein or per glass of milk, we have a much lower carbon footprint in the United States than they do globally. And this is really because we've developed a lot of production efficiencies. We've increased our meat and milk production. We have nutrient-rich diets, so there's not a lot of, they're getting the protein and things that they need without a whole lot of the extra cellulose and releasing a lot of methane. We've improved our vet reproductive efficiency. We have better health care so they don't die as easily. We have improved genetics. And so as we do that, as we increase the production of our meat and our milk, and we lose fewer animals to sickness and death, we decrease per production of unit of protein or glass of milk, we decrease our maintenance costs, because there's just a cost to just keep that animal alive. There's so much energy that has to go into keeping that animal physically breathing and staying alive. As we decrease that maintenance cost per unit of production, it helps lower global carbon footprint. So Dr. Frank Mittliner out of UC Davis has done a lot of work with greenhouse gas emissions, and he actually has reported some really interesting things. So he reports that in 1950 we had about 25 million dairy cows. In 2018 we had about 9 million, and yet in 2018 we produced 60% more milk than we did in 1950. We have increased our production so much, we've been able to reduce the number of cows, and yet we still are producing more milk. That helps lower our carbon footprint. The developing countries aren't to that level yet. And I'm not saying that that's entirely perfect, but if you're looking at the greenhouse gas emissions, there are some definite benefits to having a more intensive system. The other thing that Dr. Mittliner has pointed out, and is a really, I think, good point, as long as our livestock numbers stay the same, the methane that's being emitted by the cows will basically stay the same. And that's because it's all in a big cycle. If you remember, methane only lasts about 10 years. So, and our cows eat plants, and plants grow because of a process called photosynthesis. And you probably all remember back to those biology days, but the sunlight hits those plants, they pull out carbon dioxide from the atmosphere, so they're removing one of our greenhouse gases. They produce the plant material and release oxygen, which we and the cows need. So this, we always liked it because that's what helped give us oxygen, but it is also reducing some of our greenhouse gases out of the atmosphere. So those cows eat the plant material. A lot of it is released as methane, just from their digestive process as it goes through the rumen. That methane lasts about 10 years. It goes through a process called hydroxyl oxidation, and it's converted to carbon dioxide. So the methane goes from the atmosphere, it's converted to carbon dioxide. It's going to stay in that carbon dioxide form for about 1,000 years, or until a plant utilizes that carbon dioxide and produces new feed, so new forage or new grain for our cow. So the amount, all of that carbon that's going into that cow came from plant material. It's then ultimately going through a methane and then a carbon dioxide cycle, but then it's being pulled back out in the plant material that the next cows will eat. So as long as our cow numbers stay the same, we're really pretty much in an equilibrium. That methane doesn't increase, and it's just going to be in a bigger loop. Now, if we change our livestock numbers, that will change. So how are we doing at reducing our greenhouse gas emissions from agriculture? Let's first take a little look at where we're at. So over time, as you look at this, and agriculture is the red line there, it looks like we're not doing too bad. We've actually had an 11.6% increase in our agricultural emissions over these 28 years or so. How can we reduce our emissions? We should all be trying to look at ways to help protect our environment. We can see that we probably are going to run into some issues somewhere along the line, but there are things that we can do. So from soil management, one is just really watching our fertilizer applications. Don't over apply nitrogen fertilizer. Not only from an environmental standpoint, it can leach, but we can lose a lot as nitrous oxide if the conditions aren't right, especially if it becomes too wet or a little bit saturated and anaerobic. But it's also costing you as a producer a lot of money to have fertilizer that's being lost to leaching or to volatilization. We want the plant to utilize that. We don't want to just be dispersing it out into the atmosphere. So that might be applying fertilizer through split applications. If you're moving into a pivot system, you can apply the nitrogen fertilizer in the pivot water. My brother is doing that now. So that's one way you can really help time it so you have the fertilizer there just as the plant needs it. We can use slow release fertilizers or nitrogen inhibitors that help slow down that nitrogen cycle so it's not converting to nitrates so easily. We can incorporate our manure and our nitrogen fertilizers. If they're sitting on the surface, we lose a lot of that nitrogen. doing our soil and plant tissue testing so that we can tell how much our plants really need. Avoiding or improving our drainage, so avoiding saturated soils. Fortunately, we don't have huge issues with this in a lot of the places in Utah, but if you have really wet, saturated soils, trying to help find ways to improve that drainage can do a lot to helping maintain the nitrogen there and not losing so much to those greenhouse gas emissions. We do recommend conservation tillage and maintaining residue. Now this has a trade-off, but overall it's a good thing. So as we improve our conservation tillage, maintain residue, we're building up organic matter in the soil, so the soil can hold more of that organic matter. It then also can hold more nutrients, so it has the better ability to hang on to the nitrogen and the phosphorus and nutrients that we want to maintain. It helps improve the drainage. But as we also, the trade-off is that as we improve that carbon dioxide or the organic matter in that soil, we do have more microbes. There will be a little bit more carbon dioxide being released from the microbial degradation. Overall, we're still better off with the conservation tillage and improving the residue. But there's a little bit of a trade-off. It's not just a complete, perfect, it solves all of the problems. Fallow is actually attributed to losing a lot of greenhouse gases. And if we can have a living root system year-round to capture the nitrogen, not let it be lost, and maintain it, whether through cover crops or perennial crops, that's a good way to help reduce greenhouse gas emissions on the crop side. From the livestock side, we're doing a lot of it. So our production efficiency, the more we can improve our production efficiency, the better off we are. So the better feeds and feeding techniques. In that study that Carrie was referring to, we're looking at having the livestock, the cows graze grass legume mixtures, with the legume having tannin. Tannin helps actually bind that protein in the rumen so that they should be emitting less methane and losing less nitrogen in the urine and feces, so that more is available for the plant to absorb for meat production or milk production. Improving our genetics and reproductive health, our animal health. Manure management, we can do a lot there. So if you apply manure to a field, incorporate it right away. That helps do a lot. As far as greenhouse gas emissions, aerating the manure actually helps reduce the greenhouse gases that are being produced. Or we can put on covers or use anaerobic digesters and try and capture that methane a different way. Composting is beneficial. And the other one that we don't oftentimes really think about, but if we improve our grazing lands, we can actually reduce our greenhouse gas emissions. So by improving the grazing ability, and a lot of times that's just by putting in a rotational grazing system, we improve the forage productivity, which helps build up the carbon in the soil that's trapped. But we're also seeing a huge benefit in just the increased productivity from the forage, and then the number of cows that you can have on that land and support off that land. So just grazing improvements can do a lot. Okay, with that, I think I've covered a lot of numbers for you today, and so I will stop it at that point. If you have questions,